All right, everyone, and welcome to the very first video. As a reminder for this class, for the videos, especially for chapter 1, because everyone might have like different levels of knowledge. You might have different backgrounds. Especially for this first chapter, if you're comfortable with lines, if you're comfortable with marginal cost, if you're comfortable for all this stuff, go ahead and just start doing the homework. And then if you ever get stuck in the homework, then you can always come back to the video and watch it 1 or 2 times, okay? And remember that I'll also be including the PDFs of all of this whiteboardage stuff. So you can always consult that as well and then look at the video if you need more assistance. And of course, always ask me questions via email or Slack or something like this. So let's get going. We're going to start by talking about finding the equations of lines and formulas for lines. So it should be a refresh for all of you, but we're going to start with introducing 2 main formulas for line, okay? So the first one is slope-intercept. All right, and this is the most popular one, and that's just going to be y is equal to mx plus b, where m, remember, is the slope, and b, remember, B, remember, is the y-intercept. Remember, it's the y-intercept where it crosses the y-axis. Y-intercept because y-axis, okay? Which is when the x-coordinate is equal to 0. All right, and that's the popular one. But the other one that is really, really useful, but is less popular for some reason, and I'm trying to do my own part to make it more popular, is point slope form. And that's going to be y minus y1 is equal to m times x minus x1. And this one is super useful. Now you might say, well, Jason, when do I use which formula? Well, that's the best part, is that the answer is in the name, right? You use slope-intercept form when you've got the slope and the y-intercept. You use point slope form when you've got a point and a slope, okay? So that's all there is to it. You always know which form to use, unless you don't have either of those things, in which case you need to get one, all right? So those are the formulas. And again, I didn't clarify right, but m is the slope here, and the point x1, y1 is on the line. So let's get into it. Just do an example problem, give you some practice. If you're already good with this, feel free to go on with the homework. But here we go, over to the next page with example 1. All right, so example 1 is going to be find an equation for the following. Well, let's be even more precise. For the following lines. All right, and a big a big little thing, just a small thing, right? Is it says find an equation. Okay, there are infinitely many equations for the same line. You just need to give me one. If you want to give it to me in point slope form, that's fine. If you want to give it to me in slope intercept form, that is also fine. Okay, so you can use either form you want. Some people have preferences. I do not. Okay, so use the form that you prefer. All right, choose your own adventure here. And what wonderful adventures are we going to have? All right, so part A is a line with the slope of -1, and the point 7, 1 is on the line. Okay, so what do we have? We have a slope, we have a point. Let's see, if we have a slope and a point, which one are we going to use? Well, point slope. All right, so we're going to start by writing the formula down. Okay, we have y minus y1 is equal to m times x minus x1. Remember, x1 is the x coordinate. I'm pointing to it, but you can't see it. And then y1 is this thing. So we just replace it. Right, if we go over here, say the 7 is our x1, and the 1 our y1. All right, then we just substitute out. Y minus 1 is equal to m, which is our slope, -1, times x minus x1, which we said was 7. And that is the equation of our line. And again, this is point slope form. This is a final answer. This is an equation of a line. You could also rewrite this into slope intercept form. That would also be acceptable, but you don't need to. Okay, that's a perfectly good place to be. There's a bunch of variations on these problems. That's why you've got a lot of homework problems, just to make sure you know every permutation of what this could look like. All right, so let's just do a couple more real quick. What if we have the point 1, 2 and the point 3, 5 on the line? That's not an L. So let's see. We have 2 points. So with these 2 points, are we going to use slope intercept? We have neither the slope nor the intercept, so maybe not that. Or are we going to use point slope? We have 1 point. We don't have a slope though. So this is the better option right here, but we still need the slope. We need to find the slope, okay? So remember that for slope, it's rise over run. Or another way of writing this is y2 minus y1 over x2 minus x1, right? Rise is just, what's the difference in the y values? Difference is subtraction, y2 minus y1. Run is the difference in the x's. Well, that's just subtraction of the x's right here. So we just do that. Take this y and subtract that y. That's going to be 5 minus 2. Take this x and subtract that x. That's going to be 3 minus 1. And you just simplify, it becomes 3/2. Even better if the 3 looks like a 3. So that is our slope, and you can't see that at all. All right. Well, this is a learning experience for all of us. But yeah, 5 minus 2 over 3 minus 1. Let's show that over here. 5 minus 2 over 3 minus 1 is what we had, which simplified down to 3/2. Right. Okay, so that's our slope. For the point, remember we had 2 points. We can use either point. All right, either point is okay. I'm just going to use the first one because, I don't know, it's first. The point 1, 2. All right, so our point is 1, 2. Let's use point slope form, which is again y minus y1 is equal to m times x minus x1. And again, one of the reasons why I write this formula over and over and over again is because the more frequently you write down a formula, the easier it is to remember it. Okay? So it's good for muscle memory. It's also good for just easily plugging in, right? We're plugging things into what's right above it. Y1, we said was that 2. 2 is the y value. The slope we said was 3/2. X1 is that x value up there. And again, these are just directly plugged in. All right, just like so. And that's our answer. Okay, that is the equation of our line. There are many equations. We could have used the other point. That would have looked a little different. We could put it in slope intercept. That would have looked a little different. A lot of different ways to make these answers look, but they're equivalent. Okay? There are infinitely many right answers. So if you get a wrong answer, you got no, just kidding. Let's move on to a couple more, okay? All right, so, oh dear. Grid is the wrong size. Well, we don't need a grid for this anyway. Get rid of it. I'll fix that later. We'll do graphing in the next one. All right, part C. We need a horizontal line through the point 3, 2. So horizontal and vertical are new things that we haven't talked about yet, and they're just keywords, right? And you have to translate to slope. Okay, so look at this word horizontal. Let's translate. What does this mean about slope? Well, horizontal line, right? Horizontal line is a flat line. I just said I didn't need to graph anything, but horizontal line is a flat line. Flat line. Is this rising at all? No. There's no rise, so it's going to be like 0 over something. It's 0. It's flat, right? If you're just walking along on a flat thing and someone asks you, oh, how sloped is this? You say, not at all. This is flat ground. Okay, so horizontal means m is equal to 0. All right, so we have the slope, we have a point. Let's use point slope form, shall we? So again, it's y minus y1 is equal to m times x minus 1. The y1 is 2 here. The slope is 0, and the x1 is that 3 up there. And this is a perfectly good answer. It's not fully simplified. 0 times anything, right? This all becomes 0 up here. So really, we could just have y minus 2 equals 0. This is a good answer. Or you could have y is equal to 2. Both of these are okay. All right. I'll accept either one. And that's what horizontal means. Vertical is a little trickier. I don't think there are any vertical ones in the homework assignment. Vertical, the slope is infinity. So it turns out to be an equation like x is equal to something. There's no vertical ones yet. All right, let's just do a couple more. And again, if at any point you say, Jason, I got these already, that's fine. You can pause the video and start working on the homework. This is just for people who want the refresher, who want to see more of these problems, okay? So if you want them, they're here, but I'm just here for you. I'm not here for me, you know? If I wasn't teaching this class, well, I might still be recording videos anyway, just because it's something I like to do. But anyway, let's do another one. Part D. All right, find a line, the equation of a line whose slope is -1/2, and the x-intercept is -3. Now you might say, hey, this is my time to shine, Jason. This is my time to shine. We've got a slope, we've got an intercept. Let's use slope-intercept form. But remember that this is the y-intercept, and we don't have a y-intercept. So even though you're super excited that we have a slope and an intercept, we can't really use slope-intercept form here, which is a little sad. Okay? So the x-intercept is -3. Remember, x-intercept is where it crosses the x-axis. Okay? So if you wanted to, you could visualize this on, let me try this again. Oh. All right, if you wanted, sorry, we are having some technical difficulties. If you wanted, right, remember the x-axis. When x is equal to 3, it crosses the x-axis. What's the y-coordinate here, right? The y-coordinate here is 0, and the x-coordinate is 3. So we do have a point right here. Be very careful to translate it correctly. You cannot use slope-intercept form here, right? So again, this is still our m. This is still our point. We still got a point and a slope. It's point-slope form all day. This is why, despite its lack of popularity, I love point-slope form. You can use it on almost anything. All right, so again, we just get y minus the y-coordinate, which is 0, is equal to the slope, which is -1/2, times x minus the x-coordinate of our point, which is 3. And there we go. We've solved another problem. Hooray. 2 more on this video if you want. Do part E. Again, as a reminder, if at any point I'm going too fast, feel free to stop the video, feel free to pause it, feel free to rewind, feel free to slow it down, etc. All right, let's do 2 more. Let's find the equation of a line that is parallel to the line y minus x is equal to 5 and passes through the point 2, 1. We haven't talked about what parallel and perpendicular mean yet on lines, right? But we know kind of intuitively what it looks like for 2 lines to be parallel, right? This line are mostly parallel. They're supposed to be parallel. Okay. Parallel means they have the same slope, right? These are the same levels of steepness. Okay. So that's the idea right here. Okay. Anytime you see parallel, that means same slope. So all we need to do is find the slope of this original line that they gave us, and then use point slope form again with this other point that they told us. All right, so what is the slope of this one? I don't know. One easy way to find the slope is to put it in slope-intercept form, okay? So if we put y minus x equals 5 in slope-intercept, hey, we're finally getting to use it. It gets a little easier. So we need to add the x over to both sides. Now we're going to get that y is equal to x plus 5. And remember, x plus 5, that's the same as 1x plus 5. So the slope is 1. Now we need something that's parallel to this line that we just found. Parallel means same slope. Our slope is still going to be 1. But now it's passing through this point instead. Okay? So we're going to have y minus the y coordinate, which was 1, is equal to m, our slope is still 1, times x minus the x coordinate, which is 2. This is a line, oh my word, that is ugly. This is the equation, an equation, a line that is parallel to this first equation, and that also passes through this point. All right. Last one, very, very similar, okay, is going to be how to do one where it's perpendicular, okay? So part F, something that's perpendicular to the line, let's say a y minus, say 2y minus x is equal to 6, and it passes through the point 1, 2. Oh, let's do negative 1, 2. We haven't done a lot with negatives today. So perpendicular is related to parallel. Parallel means same slope. Perpendicular means negative reciprocal. Okay. Perpendicular, sometimes it's abbreviated like that, means, I bet that looks weird. Perpendicular means negative reciprocal. All right, so for example, right, if we have 2, the reciprocal of 2 is 1/2, and we make it negative. If we have negative 3/2, the reciprocal of 3/2 is 2/3. The negative of a negative is positive. So this is what it means, negative reciprocal. Okay, so first, again, we have to find the slope of this original line. And then we're going to find the negative reciprocal to find the slope of our line. All right. So, goodness. Originally, I said these videos are going to be 5 to 10 minutes long for most of them. This one is a little longer, but they're just bonus examples. You're getting some free mathematical content today. All right. So let's add an x to both sides. We're going to get that 2y is equal to x plus 6. We need to divide everything by 2. When we divide x by 2, we get 1/2 x. When we divide 6 by 2, we get 3. All right. There, you can see it now. So the slope of the original line is 1/2. But remember, we want perpendicular. So we need the negative reciprocal of 1/2, which is negative 2. Okay. So we take the fact that we know the point it passes through. We know our slope. So let's plug it into point slope form. All right, so we're going to get y minus the y coordinate, which is 2, is equal to the slope, which is negative 2, x minus negative 1. It's going to be x plus 1. All right, and that right there is our final answer. And watch this. Okay. Got our final answer right there, and you can even see it. How about that? Okay, so that's how you do these. That's how you find the equation of these lines. If you have any questions, let me know. And remember, now you do the problems that are right above this video. There's a list of problems, okay? And if you run into any trouble, just ask. All right? That's the first video.